Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Welcome to the GOTO Book Club. My name is Sheen Brisals. I'm a technology consultant, author, and a speaker. Last year, I was on the show speaking about my book, Serverless Development on AWS. Today, I have the pleasure of sitting on the opposite side, speaking to a popular author. Vlad is going to talk about his new book on coupling. I say new book because Vlad is already a popular author because he has written one of the most popular books on domain-driven design, learning domain-driven design. So it's my pleasure and privilege to speak to Vlad here on this show. Hey, Vlad, welcome to the show.
Hey, Sheen, thanks so much. It's an honor being here.
Why don't you take over and introduce yourself to everyone?
Yeah, so that's the hardest question to answer. So I guess I consider myself a software engineer. Whatever title I'm having at a job, whether it's a software engineer, an architect, or whatever, it all boils down to software engineering. That's what I love doing. Now, the thing that I'm most proud of is the one that you have already mentioned, and that's two things. The Learning Domain-Driven Design book and the new one, Balancing Coupling in Software Design. Beyond that, I'm speaking at conferences, and I try to blog, but, it's a bit dry period lately on my blog.
Cool. So, as you said, you've been in the industry for so many years, engineer, author, speaker, writer, all sorts of, activities. And coupling is a topic that is very common, but also very old as some of the mountains out there. So let's hear from you why you took this topic at this point in time in the the sort of evolution of engineering.
Yeah, so coupling and cohesion, these two terms are here for forever, I think. And I remember hearing them for the first time. It was at a meetup here, a local meetup called Software Craftsmanship Tel Aviv. It was, I don't remember what year it was. It was around 2006 or 2007. And somebody was doing a presentation and they were talking about coupling and cohesion. Now, kind of understood what coupling is from that presentation, but cohesion was a bit of an enigma for me. So I kept it there at the back of my mind for quite a few years. And then one day at the company I was working at, we decided to do a microservices-based project, an architecture that is based on the microservices style. And it failed miserably. It was such a failure in all regards. You take all those things that microservices architecture is supposed to give you, and what we got was the complete opposite. So I was trying to understand what was going on, why this microservices thing works for others, but it didn't work for us, even though we were trying to do what people were talking about at conferences, at podcasts, books, whatever. We tried to do it, got the opposite results. So I started researching microservices. It started there, but it led me to software design principles, and in the end, I found the answers I was looking for in a very good old book on structured design. It's a book from 70s, and the chapter that I was particularly interested in was called coupling. And that moment changed the way I'm thinking about software design. And then I started investing more and more time in researching this topic of coupling.
Yep.
And as I gained more and more information, I started to adapt it to make it easier to work with. And end result is this book, Balancing Coupling in Software Design.
Yeah, perfect. So you touched on two things, which is kind of leading to my next question. So you went back to the 70s when the book was written, and also you touched upon microservices. That's more like, recent times. So if I time travel back to the, 80s, 90s, basically 90s, when I was initially doing development, it was so easy to look at coupling because most of the things were homegrown. We developed applications, components, easy to relate coupling within and between the components. But now, if you take microservices you mentioned, say cloud, for example, cloud services, there are managed services and so many SaaS providers on the platform. So when we build applications these days, we are consuming all these sort of different applications or services and interfacing with everything all over the world. How do you see the concepts you explain in the book relate to the newer times, as you found the olden days, how coupling was talked about?
Mm-hmm. Yeah, the funny thing is, if you go back not to 90s, not to 80s, but 70s, even end of 60s, and you read that book that I mentioned, Structured Design, the funny thing is that the problems that the authors attempting to address by introducing that methodology, structured design, are so similar to issues we are fighting with today. Even though the technological stack was massively different, the tools they had were nowhere near what we have today. And of course, the problems they were solving with software, I don't know if it will be justified to say that they were simpler, but let's say that the solution stack was definitely more compact. Let's say it that way. They had fewer options. So the problems that we as software engineers are facing are quite similar if you look through the years. Mm-hmm. But we managed to find ourselves in worlds of pain and problems. Nevertheless, it doesn't matter what is the solution stack we are working with, we can find how to shoot ourselves in the foot with it. And it usually has to do something with coupling. And one of the motives of my book, Balancing Coupling in Software Design, one of the things I want to say is that no matter what level of abstraction you are working with, if you are working with a distributed system, microservices, cloud infrastructure, etc., or all the way down to, instructions in assembly code, software engineering revolves around the same design principles, and they apply at all those levels of abstraction. So on the one hand, it's sort of bad news that our solution stack today is so wide. But the good news is that I believe if you understand those design principles that have something to do with coupling, then it will make your life so much easier no matter what level of abstraction you're working on.
Exactly. I like that because I read the book and I was smiling at so many, parts of the book as I was reading through. Because I spend a lot of time in the event-driven architecture, serverless, cloud these days. And we always hear about coupling, and mostly we hear about, decouple, or someone will say, no, it's not decoupling, it's loosely coupling. So those are of the terms we are familiar with. But one thing you make it clear in your book is that no matter where things are, I think you took an analogy of planets, right? So even though planets are millions of miles apart, there is still coupling in sense of gravitational force, right? So that thought, kept me thinking, because that is a nice way of seeing coupling, and also making the modern engineers who are not familiar with the term or the terminology better, so that takes home the message, right? So that's a really good point to, portray coupling in the modern application, landscape. So in terms of coupling, one of the things that I found really useful in the book is that you added measurements to several aspects of coupling. You talk a lot about, the strength or the distance, so on and so forth. But have you applied these principles with your clients or in your, day-to-day work and things like that?
Yeah, of course. Of course. In order to have that confidence to write a book about it, I have to test everything I say in my own work. So everything you read about in the book was battle tested, battle proven, and it was changed because of the results in the battlefield. Because if I go back in time to 2018, 19, around that time, that's when I started applying that model of balanced coupling and integration strength.
Yeah.
And it took a number of iterations, to get where we are today. And even if I look at that point of time when I started working on the book, when I said, okay, this is it, this is something that I want to write about, even at that point, even after that point, it changed quite significantly. For example, the integration strength model, originally it had 5 levels, for example. My plan was to use structured designs, module coupling, and to make it easier to use nowadays, because that model was based on terms from programming languages that are luckily we're not using today anymore. So if you would use that model today, it would definitely make you sound smart, but no one is going to understand what you mean. So I wanted to make it as approachable as possible. Now, originally there were 5 levels. For example, there was functional coupling and logical coupling. And I remember one of the reviewers, it was Von Vernon, he said that logical coupling makes no sense because it describes something that is probably terrible, but you're using the word logical, but it's not logical to do that. And I said, okay, cool. Let's incorporate that feedback. So logical coupling went away and became a part of functional coupling, one of its degrees. And also initially there was a level called implementation coupling, which is a dependency on implementation details.
Yeah.
And then we had an hour-long conversation with Von Vernon because he didn't like that name, implementation coupling. And it took us over an hour. Sorry, it took him over an hour because he came up with that word intrusive coupling, which captures the intent so beautifully, so elegantly. And it's like the perfect word for that level of integration strength, intrusive coupling. So I guess that was the moment where that model it took its shape and form that you can find in the book today. So going back to your question, everything was tested in my work, but it took a lot of time to find that shape and form for that model that, in my opinion, is the most approachable and the easiest to work with.
Yeah. So the reason I was asking that question is because I wanted to understand, not from you, how others adopted or understood what you are kind of, proposing with these sort of calculations. Because working in the industry with engineers, one of the hardest things I notice, like problem decomposition. Many engineers struggle to, even make a start, how to decompose a problem. And then you need to give cues and, tips and tricks. So then they understand, this is how I can use this tool or that tool, etc., etc. So if you go back in those days, when we used to do estimations, we used to look at function point analysis. That used to be popular. Over the years, Agile brought in, story points and various sorts of, doing estimations. So now, with what you're detailing in the book and what you are educating engineers in the book is a way of looking at complexity and assessing the complexity. So how that can now bring more educated estimation into, application development, for example. How do you see that, slowly evolving in the minds of engineers and among the teams?
Yeah, that's a great question. And actually, it makes me a bit angry at myself that I didn't think about it when I was writing the book. Great question. Unfortunately, I haven't used this model as means for optimizing estimations, but I can totally see how it can be useful for, because the higher the level of uncertainty, the more uncertain your estimations are going to be. So the more safe buffer you have to add. So I think it can be very useful, but unfortunately, I haven't tried that.
Right. Okay. Because that's something I think will be really beneficial for engineers, because rather than just because, you know, all applications these days interact with the third parties or different domains and departments, so on and so forth. So it's really important that given that you place all the different constraints and things available, I think they will become more important, useful to have that sort of understanding and knowledge built to them. Another aspect, in addition to coupling, of course, you need to touch upon is complexity. You talked a lot about, the complexity in the book. Actually, I'm giving a talk at a conference later this month, and the talk is about embracing complexity in serverless. So I will be using references from your book, but something I noticed as I was reading through is like terminology that I think again originated from the 70s. It's about the local complexity and the global complexity. And then you apply the coupling aspects on top. Why you brought that into this book? Just to start with.
Yeah, and look, we didn't plan it, but again, it's about the same book, Structure Design, that I mentioned twice already. So now it's a third time. These two terms are from that book, Structure Design by Glenford Myers.
Yeah.
Back when I was researching my failed microservices project, suddenly I stumbled upon those two terms, and suddenly everything made so much sense that with that failed microservices project, we optimized local complexity, the complexity of the source code of each service. It was really simple. It was really micro, like really short. But on the other hand, the global complexity of the overarching system was quite high. It skyrocketed. So at that moment, I said, why on earth aren't we using these two terms nowadays? So ever since, I've been using those terms all the time. And of course, I had to include them in the book because that's the purpose of, I needed them to discuss how we usually apply, how we optimize coupling, and how in some cases we can optimize coupling on one level of abstraction, but again, shoot ourselves in the foot on another level of abstraction. Yeah. And without these two terms, it's really hard to spot those cases. So yeah, same book, Structure Design.
Exactly. And the reason I brought that in is because those simple concepts originated, many decades ago. Because these days, whenever I talk about event-driven architecture or serverless applications, I also talk about complexity at two different ways, like accumulated complexity versus distributed complexity. And also, for example, accumulated is probably a monolith where everything is local, where distributed is like you have a distributed set of applications where, things are going all over the place. So then as I was reading, I thought, I can relate the meaning of the local versus global complexity of the 70s to how we now develop and deploy and operate applications on the cloud. So again, simple concepts, but different meanings and interpretations, but still valuable, to this day. So that's the reason I brought that one in. Another aspect I wanted to touch, you spoke a few times about the failed microservices project. Now, modularity is something you discuss in the book, and there is a reason for it. Before we get there, can you just, for everyone's benefit, explain why that project failed?
Oh, because we did a lot of stupid things. So, again, let's put it in context. So the context is the early days of the microservices hype train. And we were learning from podcasts, from conference talks by people from those big companies, embracing this architectural style. And I would say that we failed because of the decomposition principle that we applied.
Right.
And that decomposition principle focused on the local complexity of each service. So we went from monolithic solutions, which were quite big, and it would take some time to grasp what is implemented there. And we went towards those services which are micro. So we put that micro around the code that is written in each service.
Right.
Now, as a result, what happened was that we deployed that system to production. Initially, it looked awesome, but then every change we had to make, it touched upon multiple services. They had to be deployed simultaneously. Otherwise, errors, collisions, mistakes, bugs, however you want to call them. So that was the issue. We focused on optimizing local complexity. We increased the global complexity, and we couldn't evolve that system because of that.
Right.
So that was the reason.
Yeah. I think that's the mistake many teams do, because they think that microservices are independently deployable, single purpose, so on and so forth. But when it comes to, coupling or dependency, they often miss the basic best practice patterns. And the reason I brought microservices into it is because, you talked about modularity. And the fact I liked about modularity, the way you pictured is like modularity, when we build modular systems in a, proper way, it avoids or eliminates the accidental complexity, because then you have a better pattern for extendability, so on and so forth. And also the essential complexity is kind of encapsulated within the sort of the module. That's a cool thing, I think it takes time for some engineers to understand these concepts, but it's something, important to get across, especially while architecting or designing applications. So in terms of, so microservices and modularity and complexity and coupling, do you see that we probably need, different pattern or a different sort of way of doing things these days, especially with the cloud in the mix?
That's an interesting question. On the one hand, I want to say that it doesn't matter because, again, my point of view is that once you understand the basic design principles around managing coupling and balancing its dimensions, then it doesn't matter. If you're developing a monolith, it's going to be a modular monolith. If you're developing a distributed system, then those microservices are going to be modular. They're going to be modules. However, on the other hand, there was an old WCF book. Sorry, I don't remember the name of the author and the title of the book. I just remember that it was about WCF framework by Microsoft. And in that book, there was a historical perspective about managing coupling, that throughout the years as our industry became more and more mature, we were adding more and more levels of abstraction to manage coupling, to fight coupling. I think those were the words that were used in that book. So when that book was written, it was in the days of SOA, service-oriented architecture. Then microservices approach kind of refined how we want to approach that distributed architectural style. And if history teaches us anything, then probably there are going to be some other level of abstraction that will be introduced, maybe tomorrow, maybe a year from now, or 10 years from now. Sometime in the future, there has to be another level of abstraction, I guess. Yeah. So I think, again, based on that historical perspective, it's going to happen.
Mm-hmm. Mm-hmm. Yeah. No, because, so for example, the event-driven architecture of these days, right? So there's plenty of, interactions or events flowing all over the place. So we are kind of, developing a network of systems with all, events flowing here and there. So more and more the awareness of, these principles will benefit teams when they come to looking at architecting those sort of, solutions. Just going to take a deviation from talking technology. Mm-hmm. Everyone knows you as an author, Vlad, but I want to talk to you about the poet, Vlad. Because usually when I write a blog post or when I write a book, I start with a phrase or a famous quote. I usually search all over the internet to find the best fit quote. You in this book took it a different way. You just came up with a simple poem for each chapter. How did this happen, and what's the background to your poetry skills?
That's quite a long story, to be honest.
Happy to hear.
So, first of all, it's no secret that this book was published 3 years late. So I started working on it quite a while ago. It was around 2021. Back then, I was trying to force myself to write something, but then, writer's block and suddenly other things are way more interesting than writing the book, than actually working. But you try to find the connection between the things that you are distracting yourself with. And if you can find some connection to the book, then suddenly you feel that, okay, I'm still working on the book. So long story short, OpenAI, back then they were not really known. And then they released their text completion API. It was way before ChatGPT. You would give a string and it will complete it. You say, okay. And I said, okay, let's play with it. Let's ask this thing to write a book for me. Didn't work, of course. And I said, and when I gave up on that, I said, okay, so the point of a book is to say that coupling is not something that you have to fight, but something that you can manage. Write a poem about it. And then it came up with those first 2 lines were brilliant. They were strong lose we live in dread of the coupling monster under the bed. And I'm like, this is fantastic. And the rest of the poem was terrible. The rest was, I don't want to recall that. Yeah. So it was terrible. I was so fascinated by those 2 lines. But I said, okay, cool. Let's get back to the real work. And I kept those 2 lines in the back of my head for some time. And then I finished the first draft, I think the second draft. And by that time, they already had ChatGPT. And I think it was GPT-3 or 2.5. I don't remember. One of them came out. It was new and groundbreaking at the day. And I said, okay, let's try to ask it to write a poem for each chapter. So again, I said, for the first chapter, these are the first 2 lines. Strong illusion will live in dread of the coupling monster in the bed. The rest, you write. Make it funny, make it about the contents of the chapter, but the goal was to make it funny. And some of them were funny, some of them were okay, but most of them, I remember showing them to Nick Tune, and he said, look, this is lame. So most of them were lame. So at that moment, I kind of decided, okay, I will just delete them. They're not that good. They're not really funny, most of them. And I cannot leave only 1 or 2 poems. And then, again, I got more and more feedback. And I started seeing that this book is heavy. This is not what people are expecting from me, because they read Learning Domain-Driven Design, where I took that methodology and I gave them 20% of the methodology that, in my experience, gives them 80% of the value. It was defined as a white belt book, And in the end, I said, to get the black belt, you have to read Van Vernon's red book, Eric Evans's blue book, and then you will get your black belt.
Yeah.
That's where you get the whole understanding of the methodology. With this one, I couldn't do it because I cannot point to another book. I cannot point to that book from 70s because it's really hard to read nowadays. Mm-hmm. So at that point, I understood that my book is becoming heavy, like way too much material.
Yeah.
So first of all, there is a lot of stuff that I had to remove in the editing process.
Right.
And then I decided that I will go back to those poems again. This time, my goal is not to make something funny, but to make those poems serve a purpose. The purpose was to give an overview of each chapter. So when the reader begins a new chapter, they have those 4 lines, which are kind of easy to read, easy to understand, and suddenly they have the understanding of the overarching theme of that chapter, what that chapter aims to communicate. And for me, it makes it easier to read the whole chapter. Now, ChatGPT still cannot write a poem as I wanted them to be. So what I had to do is to go to a grocery store, get a pack of Red Bulls, lots of Red Bulls, and I spent lots and lots of time writing poems with ChatGPT. I would say that it's a collaboration. It's 50-50. I had to write 50% of each and every poem in the book.
Yeah.
The other 50 is from ChatGPT. Mm-hmm. I had to invest so much time in writing them because, yes, I am not a poet and I'm not a writer. But being a poet is so much more difficult than being a writer, I guess. So, yeah.
No, I mean, I really like that, you brought that variation into each chapter. I was going to read, a poem, but then I thought, okay, I won't reveal the secret. So I will let listeners, buy the book, read those, poems in every chapter. And it's so cool. So cool.
If you want, you can read, by the way. I would love to hear which one you like the most, for example.
No, I had it, but I don't have the book with me, the physical copy. So I was reading the online O'Reilly platform. So, yeah, it's so cool, so cool. I think probably it'll become the trend rather than adding somebody's quotes or phrase. Now people will think differently. Okay, why don't I kind of become a variation, bring in a variation or something?
Yeah, cool. And in the end, there is this blood of copying, which kind of gives another overview of the whole book, but in a way that I hope is going to be easier to remember.
So why don't you tell the listeners where can they find your book?
The book is available on Amazon and the regular bookstores. The one that Pearson works with is called informe.com. There you can buy the PDF version. On Amazon, you can buy a Kindle version. And of course, both of them, you can buy a physical copy. Yeah, and it's also available on O'Reilly online learning platform. And if you are a subscriber, then probably you had the chance to read one of the first drafts that was published there. And if you're one of those people that read it, then I'm sorry. I'm truly sorry for what you had to go through.
So thank you. Because O'Reilly online platform is great because they bring in books from different publishers, not just O'Reilly. So it's so convenient to read everything. So before we close, any message for you want to convey in terms of coupling or complexity to the listeners?
Yeah, I guess it all boils down to going away from complexity to modularity. And we haven't really touched about concrete materials from the book in this podcast. So I will summarize complexity as when you want to do something and you don't know what the outcome of that action is going to be. That's complexity. Now, why it happens? Because of the cognitive load of the way that system is designed. You simply cannot fathom all the interactions between the components of that system. The opposite of that is modularity. I would say in 2 sentences. The goal of modularity is when you want to make a change, then first thing is, what you have to change. you can easily locate that component that is in charge of that functionality you have to modify. And the second thing is, once you make the change, you know exactly what's going to happen. So that's why modularity is the opposite of complexity. One, complexity is a result of increased cognitive load. Modularity, on the other hand, decreases the cognitive load. It makes it easier to understand that system. How to go from one to the other? Coupling. It all boils down to coupling. How those components in the system are integrated, what is the knowledge that is being exchanged between them, and what is the physical position of the components in the system. That's the book in a nutshell.
Thank you. I think very well summarized. So I think we are coming to the end of the show. So thank you so much, Vlad. It's absolutely pleasure and privilege for me to speak to you for this show here. And I'm sure the concepts like coupling and the complexities, how to measure them, will benefit many engineers of this generation. And importantly, it will bring smiles to many faces as it did to me.
Oh.
So thank you again so much. Thank you for being on the show. Thank you.
Thank you so much. And it's a pleasure being here. I loved the questions. And yeah, it's an honor to hear that feedback from you. Thank you so much.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.